Welcome back. Let's do some auxiliary views. So what you're looking at here is a funny little box with a oblique plane on it. So right in here, this 1, 2, 3, 4 is our oblique plane. And what we mean by that is that in the three principal views right here, the front view, the end view, and the top view, the oblique plane 1, 2, 3, 4 does not show up in its true shape in either of those views. So let's look what does show up in its true shape in those three views. So you got this little triangle right here in the front view. That triangle is in the plane of the paper, so it's in its true shape. And then this little triangle right here is also in the plane of the paper, so you're seeing the true shape of that. And then this little triangle up in here in the top view is in its true shape. But the 1, 2, 3, 4 doesn't show up in its true shape in any of these three primary views. See, right in here, it's kind of sloping away from the paper. Likewise, here, it's kind of sloping up, away from the paper, kind of going that way. And over here, it's kind of sloping away from the paper. So what we need to generate is this view over here, which is showing the 1, 2, 3, 4 in its true shape. So the process we're going to use to do that is a whole bunch of projections. So first you'll draw this three-view representation right here. Then what you're going to do is you're going to rotate about this axis and project on these lines. Okay, and that'll set up this kind of thing right over here. So basically by projecting along these lines, you're establishing how far things are in this direction, right? So what we need to determine is how far are things in this direction, and then we'll have a grid that we can pick the view out of. So the trick here is you go two views back. So the distances in this direction here are the same as the heights here in the front view. So that's two views back. It's sort of two rotations back. We're coming from this auxiliary view kind of through the top view down to the front view. That's the two views back rule. So this is going to be pretty easy for this view because it's there's only two dimensions. There's only two distances we got to mess with. Now we'll do that again. That is, after we've got the auxiliary view drawn, we're going to rotate it again about this axis. And we do that by projecting along these lines here. Okay, and then that'll establish how far things are across this way. So we need to establish how far things are across this way. And that comes from two views back. So we'll go from the second view through the first auxiliary view over to this view. And basically, here, let me erase all of this stuff here. Basically, distances this way in the second auxiliary view, we'll go two views back and we'll get them from distances this way in the top view. All right, that's what we're going to do. Let me kind of explain this another way. I've got a little video here running. Boxy box. There's our guy. Which, by the way, I determined the shape of this 1, 2, 3, 4 surface so that I could cut it out of paper and make this thing. Anyway, there's the front, there's the end, there's the front again, there's the top. So those are our three principal views. All right, now you do first rotation. You rotate about an axis perpendicular to my pencil, if you can imagine that. And if you line it up with the camera just right, you can get it to look like what's in the paper. So here you're seeing two planes, and neither one is their true shape. And then our oblique plane is perpendicular to the paper. So now we rotate one more time, and we bring the 1, 2, 3, 4 plane into the plane of the paper. Okay? That's basically what we're going to do. Let me let me do this for you. I'm going to draw the whole thing for you, all right? So I got AutoCAD pulled up, and this is not good. Let me pull up another, I'm using the wrong template there, so A size inches. Okay, I'm going to draw this thing. All right, so start off with the three principal views. So I'll draw the front view. I'll just make it 1.5 inches wide by 1 inch tall. So that means the side view is also going to be 1 inch tall, but I could make it a different width if I wanted, but I'm going to go ahead and make it 1 inch width. So you have some flexibility on how big you actually draw these things, as long as they agree with each other, right? As long as the 3-view ortho is correct. And that means these two lines right here that I'm drawing have to be they have to be parallel. This line and this line need to be parallel. Otherwise, the oblique plane that we're interested in is twisted. If you can imagine that, and it's some of this is kind of hard to imagine. This stuff, it does get a little bit, you know, hard to visualize. There's that guy, and there's going to be this guy right here. So let's just check. So like this point right here needs to line up with that point across. That's what I mean by a green. Here, I need to actually trim these. I'm going to use fillet radius 0 and trim that corner up. Okay, so this line has to be, lining up with that line, and this line lining up with that line, and this point right here lining up with this point over here, and here make sure here I'm using a 1/4 inch kind of in here, so make sure that this is all. Oops, make sure that right there is a 1/4 inch. This distance right in here. So the three views agree with each other, and you know what? I just feel like moving this down by a 1/4 inch. All right. That's our front, right? Our front, our top, and our end view. Let me delete this this frame. It's kind of in the way. All right, I'd like you to draw this isometric. So get into your this configuration stuff and make sure you have isometric drafting turned on, and that gives you this button right here. And set that button on isoplane top, and then turn it on. Okay, so there's getting the button. That's what this does. That just gives you the button, and then there's configuration in the button, and then there's turn the button on. So there's all that stuff going on. All right, so just sketch the isometric. You know what? This 1/4 inch snap is not particularly useful right now. I'm going to get into my snap settings down here and change this. You know what? I got to turn off ISO. Turn off ISO, then get into your, if you want, get into snap settings, and I'm going to make this 0.25. Okay. That's a little bit better. Now we'll turn ISO back on. It would have been better if I would have done that before I went to ISO, while I was drawing the 3-view ortho. But anyway, so I'm just going to kind of eyeball this, this guy, 1.5. 1, 1.5, 1.5, and then we'll come up 1. So basically I'm sketching in a cube first, an isometric cube, or box, I guess. There's our box, and then we'll cut off the corner here by drawing that line, and then this line. No. This this line, and then that line. Then there's a line there's a line there. Yeah, and then there's a line right there. And this one, and this one are hidden. And a couple of these I could trim. I'll use fillet radius 0. And I'll cut that off. And cut that off. Delete these lines that aren't really there. So that's how you do that. You draw the rectangle first so you don't get lost. Let's label these points. So I like M text because you can turn off snap here first. Okay, because you can draw a little box and it gives you the size of the thing. I'm just going to use X and whoops. You can double click that and you can actually you know what, it's a little bit too big. I'm gonna do it over again. Text, M text, more like that. And I'm just gonna use Control C to copy these, and then Control V. That's just a Windows thing, and then pop these little X's. So I'm just Control V-ing and then dropping these little guys down here. So those are all my points, and then I'm just going to number them. You can double click to edit these guys. I'm having trouble canceling the command. Let me see. So 6, and then I can left click again to cancel out of that thing. So you can double click to edit, type the number, and then you can left click off somewhere. All right. Anyway, let's do some more Control V's. That thing's still in the clipboard, and label the rest of it. You know what? I'm not going to do that, just in the interest of time, but I would like you to do that. You know what? I should do it. Because I got to be talking about these points later, so it's good to go ahead and take the time to label them, as tedious as that is. And you're welcome to, tell you what, I'll pause it and come back. Okay, magic. I did a lazy man's edit, just paused the video recording and added these numbers in there. So anyway, look, they should correspond to the isometric. 1, 2, 3, 4. 1, 2, 3, 4, like that. Spend a little time and look at these guys and double check them. Notice that some of them are coincident, like 4 and 5 in the top view are on top of each other in the top view, and 1 and 8, points 1 and 8 in the front view are on top of each other, right? Because 1 and 8 are this line up here in the isometric, so that appears to be a point in the front view. And likewise, do I have a boo-boo here? 6, 8. Yeah, 6, 8 are coincident, so that's this line here in the isometric, 6, 8, which appears to be a point in the top view. So there's that. Okay, let's do the first auxiliary view. So what we're going to do is we're going to rotate about a line, in approximately this orientation. Basically the line coming out here. Let me switch back to orthographic grid. Basically the line coming out from this point perpendicular to this line over here, we want to rotate about that line. So And we're going to do that by projecting to a line perpendicular to this. So I need to create a line perpendicular to that. So I'll just start a line kind of anywhere and then make sure I get the perpendicular snap. All right, so this line's perpendicular. Now I can grab it with the move command and just move it out here. I just need the angle that it's at. All right, I'll just drop it right there and I'll click it and then I'll lengthen it. And the other end as well. Okay, now get into your snaps. Make sure you have just perp, int, and endpoint. And start doing this. We're going to basically project all of these lines perpendicular. So we'll draw a line from each of these intersection points on the top view perpendicular to this line. So that's spatially we're sort of rotating about an axis. Okay, so what we've done is we've established the distances going this way. Now we can go 2 views back, basically the distances going this way in the front view. And we know what those are. This one's, just by looking at the grid, it's 3/4 of an inch from 5 to 4 and another 1/4 of an inch up from there. So I can just offset over here. So we'll offset by 0.75. Okay, and then offset again by 0.25. Whoops. Okay, and this grid in here, our object we seek, or the view we seek, is in there. We just need to fish it out. So I'll switch to red and heavy. And so it's easy to just guess and check. Honestly, that's the easiest way. But you can sort of think through how this works. Let's kind of let me try and do that. So this line down here at the bottom, it's got points 5 and 6 on it. And this line has 0.4 and 5 on it, right? This line here is coming from 0.4 and 5, and this line's coming from 0.5 and 6. So this line in the front view is analogous to this line up here. If you can visualize that, if you can go back to the video perhaps, or in your mind, just rotate these objects around in space. So this line that I've got highlighted has 0.5 on it, and so does this one. So their intersection here, that's 0.5. Okay, basically that's sort of the process that you can follow to do that. So we could find 0.4 in the same way, and it would be here, because 0.4 is on this line. Right in here you see the 4, and then 0.4 would be 3/4 inch up from here, or basically it'd be on this line. And so you can sort of calculate where these guys are, but honestly it's easier to just sort of guess and check. So that's what I'm going to do. Let's see, because I know what the solution is, so I can kind of cheat a little bit and just draw the thing. I think that's it. And this guy back here is a hidden line, right? One of these is a hidden line. No, this one. That one's a hidden line. And I'll make it cyan. All right. That right there is the first auxiliary view. The hidden line is between points 4 and 5, which is in here between points 4 and 5. And in the isometric view, it's here between points 4 and 5. So I realize spatially this is kind of almost at the limits of human spatial processing. I understand that this is a challenging drawing to do, but that's why we have the process to follow. So just do what I'm doing here. So let me trim up this thing just so that it looks a little bit prettier before we go on. Okay, we're ready for another rotation. So now we're going to rotate about this line. So what I'm going to do is I'm going to copy this guy just from an arbitrary point in space out to about here. They just need to be at the same angle. So I'm going to change this back to a hairline line, a construction line. Whoa. Sorry about that. Okay, now let's grab him and you know what? He needs to be a little bit further away. So I'm sorry, I'm trying to do a move here. So click the thing, move. Right about there. That's about as far as I can move him before he's bumping into the other guy. I think that'll work. Okay, then lengthen him a little bit because we're going to project. We're going to project to him. Okay, so now what we're doing is we're going to project all of these points in the first auxiliary view over to that perpendicular line. And, sorry, my mouse is going crazy here. Apologies on that. I think I got it. I think I got it under control now. All right. Anyway, so project all of these points perpendicular like that. Go to every point in the first auxiliary view, draw a line perpendicular to this other line. I guess you could call this other line the rotation line. Because we're kind of simulating what would happen if we rotated about that line. Kinda. Okay, those are all my lines. Let me trim up a little bit because it's going to get uglier. All right. So basically these projection lines that I've drawn right here, they're basically establishing the distances in this direction. Okay, what I need is distances perpendicular to that, which I can get from going 2 views back. So I'm going to construct some lines here that will give me those distances by doing this. Copy from some point out to here. You just want a line here that's perpendicular to this. That's it's hard to visualize, but that's the, think of it as just what you do, the process that you follow. Some of this most people I've found can kind of understand this at a somewhat intuitive level, but it's actually hard to articulate what's happening here. Just follow the process. This is very deep back in the human brain, back in the visual processing centers. It's not easy to talk about. Vision is old. Okay, there's a missing line here. Let's see, I got to get all these points there. Did I get them all? That's it, right? That's them. So this little construct that I did is basically giving me distances perpendicular to these distances over here. Okay, so just grab all of these guys like this, copy. Okay, you want to grab this corner, stick it over here. All right, do that. Then grab all of these guys again, do a rotate about this point, click reference. The center will be here. Start of our angles here. The end of our angles here. Do that. Then you could do a stretch, because these guys are going the wrong way. So you could do a stretch. And we're lucky we can grab all of those guys. And, whoa, no, not working at all. Let's do, I'm just going to lengthen them individually with perp snap. We need that. I could trim off the extra. Okay, now we've got a grid, a perpendicular grid, whoops, right in here where our object is in there. We just got to pick it out now. So let's go to heavy red. Maybe a little heavy, maybe just a little bit heavier than that. Let's go that heavy right there. All right, so where's our first point? Any bets? Oh. How about that one? That would be 0.3, right? You think? There it is, 0.3. How do we know? Because, well, this line goes down to 3 here. And this line, it goes to 3. And this line, so then we'll follow this line. And let's see, the second one down from that is this one. That's 0.3 here. Okay. So, you know, you can do that. It's hard, right? But it's easier, honestly, to sort of guess because I'm giving you the solution printed out. Guess and check, basically, is the best strategy here. One more. Let me get our shape. There's our shape with a triangle stuck on it. This. That's our answer. That's 1, 2, 3, 4. And you could prove it by looking at the intersections. This line here corresponds to this line, which has 0.2 on it. And this line corresponds to this line, which has 0.2 on it. So the intersection of this line and basically the intersection of that line and that line gives you 0.2. Yeah, it's hard to just talk about, but anyway, let's see. Just finish this guy here. Is that it? That's it, except for the hidden lines in the back, which maybe 0.7 and goes to 0.6. Looking at the ISO, it goes to 0.6, which is where's 0.6? One of these guys, right? It's the third one over. It's the third one of these. These are the lines up in here. It's the third one over, which would be this one, and it's there. Is that it? No, it's 0.6. That one? Yeah. Sure. That is an angle of 236, and that's an angle of, I think that's 236. If I draw it backwards, it'll add 180. 236, that one, and 236, that one. This one is 307, and that's 307 plus 180 would give you 307. They have to be parallel, right? Yeah, and then these points should line up, right? And we should get some kind of a parallelogram for the base, right? This is the base right here, which you'd expect to be a parallelogram. And then the back side, you'd also expect that to be a parallelogram, which is those guys. So anyway, this one, and this one are hidden. Okay, so it's barely, I found most people can barely visualize this, but that's why we have the process. Okay, that's why we have this mechanical process, which we could go into more detail about how this process works, but honestly, it's if this is the first time you've done this, it's best to just kind of follow the solution. So that's what I'm asking you to do, is take this thing here and just go through the process and generate this thing. All right, and know that this is about as hard as it gets. And if you want to do something harder than this, you need another tool. All right. So that's it for this drawing. I hope that was helpful to you, and I'll see you next time. Bye.